Hi everyone, Sir Keji here. Today we're going to construct a frequency distribution table and cumulative frequency table using Microsoft Excel. I'll go ahead and share my screen first. So there. Considering this problem, we are asked to create a frequency distribution table and then cumulative frequency table on the calculus scores or midterm scores of senior high school students in XYZ University. We have collected the data from the senior high school students, assuming that these are the scores of the senior high school students in XYZ University in calculus. And this is the raw data, and at the same time, these are still ungrouped, and we are to group this data using frequency distribution table and then cumulative frequency table. The first step in constructing the FD table is to get the maximum and the minimum value of the data set. In Excel, we have a formula for that one. For the maximum value, the formula is equals to max, and then open parenthesis, you can select the data set. And then for the minimum value, we type in equals min, and then open parenthesis, and then select the data range. So our maximum value is 100, and then our minimum value in the data set is 50. Now we will get or compute for the range of the data set or the data points. In computing for the range, it's just simply the difference between the maximum and the minimum value. So it's 100 minus 50, that is equals to 50. The second step is to determine the number of classes. The number of classes is the row of the frequency distribution table, or the number of rows in the frequency distribution table rather. And we have the Sturge's rule in order for us to compute for the number of classes. I hope you recalled or you have watched the previous discussion about the basic concepts of probability and statistics. The formula for Sturge's rule is 1 plus 3.322 times log of n. So we need to get n first, or the number of observations in the data set. In Excel, we can use the formula count A to count the cells that are not blank within the data range. So the formula for that one again is equals to count A and then select the data range and then close parenthesis. So our number of observation here is 60 points. So if you're going to count this one by one, it should be equal to 60. And then for the number of classes, we have the formula 1 plus 3.322 times log of the n, or the number of observation, which is 60. Our k here is 6.9. And for the number of classes, we always round the value up in order for us to cover the extreme values that are not covered by the decimal places. So if you're going to round up 6.9, this becomes 7. And in Excel, you can also use the formula round up, and then just round up, and then just select the number that you wish to round up, and then comma the number of decimal places. So let's just have 0 decimal places. So it should be equal to 7. And then the third step is to determine the class interval. The class interval is the space between the first boundary and the second boundary. So it's the difference. If it's a space between the two boundaries, it should be the difference between the next next boundary and the first boundary. So in computation for the class interval, we have the formula range divided by k. So our range here is equal to 50, and then we divide it by k, which is 7. So our I, or class interval here, should be equal to 7.1. And then same with number of classes, we also round up or around the value for class interval up to cover the extreme values in the decimal places. So I here should be 8 because we rounded up 7.1. And our next step is to construct now the frequency distribution table by tallying the frequencies within the class within the classes. So we know that our number of rows or our number of classes is 7. So we are going to count the number of rows here. It should be equal to 7. So it's 1, 2, 3, 4, 5, 6, 7. So this is correct. And then for the class interval, again, by definition, is the difference or the space between the two boundaries. Our first lower class boundary here should be 50 because that is our minimum value. And therefore, our next boundary should be 50 plus 8. This should be 58. And then if you are going to copy this formula along here or the other parts of the cell or other parts of the table, we can actually press F4 on the particular cell that you wish to freeze, because as you notice, if you're going to copy this one to the next cell, the formula goes along with the movement of the copying of the formula. So if you copy the formula downwards, the cell here also moves downwards. As you notice this red box here, we're going to copy this one, so it moved along with you. So there's a way for us to freeze it. In order for it not to move, we can press F4. and you can see the dollar sign beside the row, which is 20, and then the column, which is C. So that indicates that that particular area in the cell are being, or particular area in the spreadsheet is being frozen. So if you're going to copy now the formula, the cell C20 did not move, so it's frozen in place. Okay, for the first upper class boundary, it's normally the number before the next lower class boundary. So if our next lower class boundary here is 58, our first upper class boundary here should be 57. So it's -1 lang. And then we use the same formula that So it's for lower class and upper class boundary. So it's 57 plus 8, and then we press F4 to freeze the cell, and then just copy and paste. So there. So this is our class interval. So this is what our class interval would look like. And then our next step will be to count the number of occurrence, or we are going to tally the scores that fall inside 50 and then 57. If you're going to rewrite our table, it would look like this: 50 and then 57. Wait. So our data set or our frequency table would look like this. 50 to 57, 58 to 65. By the way, this is the same. You don't need to follow me doing this. But if you'd like, I can explain that we use the ampersand symbol here for the formula. So the ampersand symbol indicates that you are going to copy the text format of the values. Because normally if we do it in Excel, 50 minus 57, it assumes that it's a mathematical equation. By using the ampersand symbol, we denote that the values are on text format. So we negate the fact that these values are numbers. So we convert siya into text. So if you're going to paste it along the formula or along the table, so as you notice, wala siya ni minus. So it didn't compute its mathematical denotion. And now we are going to count the frequency. Normally, what is being done is we arrange the data points in descending order or ascending order. This is the common practice, but we have an easier way for us to do that in Excel. But for this case lang, let me show you how it's normally done, or the common practice that is being done. The first way is to arrange the data set in descending or ascending order, and then counting it manually based on what points or what data lie inside the classes, which is 50 to 57. So we are going to arrange this data set. You can use the filter function here at the upper right side of the screen or in Excel, and then sort smallest to largest. So it will arrange the data set or the data range into ascending order. And then we are going to count or tally the scores that belong to 50 to 57. So pila man eh. What are the points that lie inside the classes? So it's 50, 51, 52 until 57 until here. So we're going to count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we're going to count 14 here. And then for 58 until 65, so it's here, from here until 65. So it's here. We don't have 65 here, but we have 64 as our highest point in the second class. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 here. Imagine if you are going to deal with a lot of data sets. So this is very time consuming. If you're given thousands of data points or hundreds, it will take a lot of time if you do it like that. So in Excel, we can use the formula count ifs. So you're going to count several criteria because ifs man siya. There are two count if function in Excel. We have the count if without the S. So you're going to count the particular cell given only one criteria. But if there are if there are more than one criteria, you can use count ifs. So in this case, our criteria will be, it should be greater than or equal to 50, but less than or equal to 57. So we are going to count the values within that criteria. So count ifs, our first variable here is the criteria range. Our criteria range will be this one. We can press F4 to freeze the that particular cells or particular range, and then comma, our criteria one again is it should be greater than or equal to 50. Please take note that in using countifs, our criteria should be placed or enclosed in a quotation mark. So we have a quotation mark here first, and then it should be greater than. So the symbol for greater than is this one, or equal to. No, it's less than. Sorry, greater than or equal to 50. So that's our first criteria. And then our second criteria is we select the range again. And it should be less than or equal to 57. So it should be 14 here. So it's the same, right? We have the same result. So we can just copy the formula and then just edit the lower and the upper class boundary. So it's 58 and 65. So it's 10. And then here is 66 and then 73. So it's 8. You can copy the formula na lang. And then this one here is 74 and 81. Here it's 82 and 89. Here it's 90, 97, 98, and 105. So there. Now we have the frequency distribution table of the midterm scores of the senior high school students in XYZ University. So we now have, or we have now grouped the ungrouped data earlier. And our fifth step for constructing frequency distribution table is to graph the table. To graph the table, we select this one first, and then we can click insert here in Excel, and then just select the normal bar graph. By the way, we are not going to present the frequency distribution in bar graph because bar graphs are only used if we're going to compare two or more. In fact, three or more is required for bar graphs, three or more categorical data. For frequency distribution table, we are going to present it using histogram because we are more interested on how the data set are arranged in distribution. You can click the bars here, and then you can click format data series, and then in this side here, the format data series, there is a gap width here. Sorry, there's a gap width here. You can set it to 0 so that there will be no spaces in between, and then you can go back to this one, and then you can select border so that it won't look compact. You can have a separator or a border there as black. So if you're going to graph the table, it would look like this. Okay, so we now have an insight on what the distribution of the scores look like. So it's right skewed. We can say that it's right skewed, but we can't say that it's normally distributed because normal distribution is shaped like a bell. And we have an outlier here, which is 90 to 97. But most of the students, by just looking at the graph, we can infer, or we can say, or we can describe that most of the students' scores are within 50 to 57. So that's how we make use of the graph in the frequency distribution table. We are also asked to get the cumulative frequency distribution table. For the cumulative frequency distribution table, we are just going to accumulate the values or the frequencies within the data set. So we are going to copy this one, the frequency, what we have acquired in the frequency distribution table. And our first step here is to get the cumulative or accumulated frequency or cumulative frequency. I think that's the right term, cumulative frequency here. The cumulative frequency is just the accumulation of the frequencies from the first and the second classes. So our first cumulative frequency here is 14 because our first frequency is 14. And then our next cumulative frequency will be 14 plus 10, which is the next frequency in the next class. And then we're just going to copy and paste the values or the formula because it's the same as we go downward in the table, and then we're going to get the total or the sum of the cumulative frequency to this one. Our next step will be to get the relative cumulative frequency. The relative cumulative frequency is expressed in, no, not yet. The relative frequency first. The relative frequency is expressed in points or percentage on which the cumulative frequency covers the total cumulative frequency. The formula for that one will be 14 divided by the total cumulative frequency, which is 273. And then since this is true for all of the rows in the data set, we can press F4 here so that we can freeze the formula. We'll just copy and paste this. Oops, sorry. So there, and you can press this icon or button here in Excel, this one here, to increase the number of decimal places. You can click increase decimal, but if you're going to decrease, just press this this button pointing at the right side. So there we have reduced the number of decimal places by 3. And then always take note that the sum of the relative frequency is always equal to 1. If it's not equal to 1, you need to investigate or check your computation. And our last computation will be the cumulative relative frequency. So the same with the cumulative frequency, we are going to add the first relative frequency to the second relative frequency. So our first relative frequency here will be 0.051, and then we're going to accumulate it until the last class, which is 98,100. So it's 0.051 plus 0.088. This one. We'll just have to copy and paste it. And always take note that our last class should have the a cumulative relative frequency equal to 1. And then for the cumulative frequency, I always take note that the last class will have the total number of observation. So as you notice here, our N is 60, and our last class here should have 60. And then, yeah, for cumulative relative frequency, the last class will have relative frequency equal to 1, or cumulative relative frequency. And in creating a graph for the cumulative relative frequency, we're only interested with the class and the cumulative relative frequency. So you can copy it and then right click so that the formulas will not also be copied. You can select this, you can press Control C or copy, and then when you're going to paste it, you can select this one. You're going to paste the values only, so you're not going to paste the formula. So we are only interested in this one so that we can graph the ogive. So the ogive shows or is a graphical presentation of the slope or the steepness of the frequency. And then in graphing for the ogive, we select the data set and then we click insert and then just select this one line or the line graph. So this is what our ogive graph would look like for cumulative relative frequency of the midterm scores of senior high school students in calculus. So what does the ogive tells us? So as again, the ogive displays the steepness of the frequency. This also tells us how high in terms of percentage or how low the students perform or the data moves as it gradually increases. And it also tells on what particular frequency has the lowest increase in cumulative frequency. Okay. So I guess this wraps up on our construction of frequency distribution table. I hope you learned something from me today. Thank you so much for watching this video. I hope you have a wonderful day ahead. Goodbye.